Welcome to WasmAssembly episode 16. After 2 episodes in a row with people from Google, I have not 1, but 2 external guests again. Welcome Patrick Dubroy and Mariano Guerra.
Thanks for having us.
Thanks for having us.
Yeah, so the two of you are the authors of a book called WebAssembly from the Ground Up, an online book to learn Wasm by building a simple compiler in JavaScript. Simple compiler, does this even go together? We will see. It's been in the works for the last 2.5 years, and you have officially released it a few weeks ago, or months ago actually by now. So first of all, congratulations, what a massive achievement.
Thank you.
And so maybe just a very quick disclosure. I was given 100% discount code to check out the book, but of course I don't profit in any way from the sales of the book. There's another similar course called Learn WebAssembly by Dominic Elm, which actually you link to in your resources at the very end of the book. And both are linked from the website of WebAssembly.org in GitHub issue 278. So yeah, it is formal disclosure. So just so you know, we're not in any kind of way profiting from the sales of this book here at Google. It is purely about the content. Right. And with this out of the way, before we dive into the book, let me first ask you, what led you to writing a book? Where did the motivation come from? What was your background when you started? And maybe most importantly, where did you find the time to write a book?
So, in general, about writing a book, for some reason, I always liked learning by trying to teach. It's kind of a hack. For a long I have a blog for more than 20 years, and I usually write tutorials. When I'm learning something, I write a short tutorial for myself, but also to really get deep into the thing, and also if somebody else finds it useful. And many years ago, something that started as a talk I was giving about a framework called Reacore turned into a tutorial that turned into a short book, 100 pages, called the Little Reacore Book. And I really enjoyed the process. So I was thinking like, I would like to do this again with something else. And from the beginning, I've been following WebAssembly from 2015. I went to check to Wikipedia when it was launched, 2015. And in that year already, I submitted a PR that was rejected because the feature that I was submitting the PR didn't end up in the MVP. Then I did for a couple of weeks a WebAssembly weekly newsletter that I stopped doing because it was so early. There was not much going on to do a weekly newsletter. And then I gave a talk the year after. I implemented a small fourth interpreter in WebAssembly. So I was playing with WebAssembly from the beginning, and always interested in following and thinking like, how can I have an excuse to use WebAssembly more? And I have a background in compilers, and like, I enjoy building them. So at some point, when was it, like 3 years ago, Patrick? We were in Munich talking, and I mentioned it to him. He might explain more on his side. And we decided to join forces and write a book on it. And the funny thing is that you mentioned like 2.5 years. And I think a couple of times I mentioned to Patrick that we should set a deadline on 100 pages and a year. And we didn't met that deadline at all. Not in the pages and not also in the years. But yeah, that on the side of general writing books and writing technical books. But on the other side, and maybe we can talk later, usually the resources available for writing compilers, or in general writing compilers, is seen as some like dark magic. And I always like to try to show that you can build simple things. And compilers is one thing you can build simply. And that I learned by the books I read, and I learned about compilers. I read 2 resources that showed simply how you can build a compiler and a virtual machine, and I wanted to apply it to WebAssembly too. So that's how I ended up trying to write a WebAssembly book.
Makes sense. And this was entirely like as a hobby project, or was this part of your day job somehow?
No, it's a hobby and interest of mine. I'm self-employed, so I can decide to use my 20% into something I enjoy. I decide when to work on what. Before WebAssembly, I was involved in the Erlang community, and before that in the distributed system community. I always have some interest that is not 100% related to my main job, but I always like keep working on things I find interesting.
And if you ask Patrick for how did that encounter in Munich go, was that like, oh crap, now we actually need to do it? Did you know each other before? Like, how did you get together as a co-author team?
Yeah, that's kind of a bit funny. We knew each other a little bit at the time, but not super well. I think we had met online. Mariano sent me a message on Twitter at some point saying, "Hey, would you like to chat sometime?" He lives in Stuttgart, so not far from me. I'm in Munich, and yeah, at some point he said he was coming to Munich, and would I like to meet up? We hung out for the day and talked about, as I remember, lots of old, obscure computing things, old movies, things like that. And yeah, he said he had this idea about doing a book, and I said, "Oh, that sounds really interesting. I'm really interested in WebAssembly. I don't know that much about it, but I think writing a book would be a great way to learn. So if you'd like any help, let me know." And so, yeah, we didn't actually know each other super well. We hadn't worked together in the past until we started working on the book together. But very quickly, I think we realized that we work well together. We complemented each other. And I think we both looked at it as an experiment. If it didn't work out, it wouldn't be a big deal. And if it did, great. And yeah, my motivation, though, was pretty similar to Mariano's. I've also always enjoyed learning things by teaching them. Sometimes have signed up to do talks on things that I didn't know that much about as kind of a motivation to learn a lot about it. And that certainly happened in the process of writing this book. I mean, I knew a little bit about WebAssembly when we started, but in the process of writing, it forced us to go into a level of detail and to just really feel sure that we understood everything about the things we were teaching. It really forces you to learn.
Fantastic. Yeah, this definitely works well. Learning something by doing it and then teaching it to others. So when you say book, is there a print edition planned as well, or is this purely online as an ebook?
Right now, it is only online. We always planned it as a digital first book. Originally, we had planned to have, we wanted to incorporate lots of interactive elements. I think one of the surprising things to us as we got further and further into the process of writing the book was that the interactive things that we wanted to incorporate, um, there was a lot more value spending time thinking about the concepts that we're teaching and what order we introduce them and things like that than the value that we got out of the interactive elements. So I think over the course of the book, it turned more and more into something that could work as a print book. And I think eventually we will probably do a small number of print-on-demand editions. We've had a few people ask, but not too many, actually.
Amazing. So if you're an editor and you're listening to this episode, definitely reach out to Patrick and Mariano. If you want to print this book, I guess they would not be opposed. But so let's get into the book a little bit. So the book is intended to be accessible to people who have no previous experience with compilers. So that's almost me. Like I did very little compiler class in university, but yeah, the approach that you take is very hands-on. You generate the Wasm binary format by hand, and over the course of the book, build a simple library to make that easier. Now, with most Wasm tutorials, they don't actually teach you how to write Wasm itself, but they teach you how to compile to Wasm. So you typically start with a hello world C or C++ program, and then you learn how to use the script and toolchain to compile that code to WebAssembly and so on. So why and who should learn WebAssembly by actually writing it?
Yeah, so that's one of the motivations of the book, is that we saw that almost all the books being written about WebAssembly were like use this other language and target WebAssembly, and WebAssembly is like a blob of bits. Don't look at them, and also this concept that was repeated a lot from the resources we followed is that WebAssembly is a target. It's not meant to be something you write or generate. It's something that tool chains do, and that, at least from my experience, generates the idea that WebAssembly is something really complex or hard to understand or big, or like only tools and tool chains can generate. Only LLVM can generate this because it's so massive or so big or so complex. And when you look at WebAssembly, not only can you write it by hand, I mean, you shouldn't be you can if you want. I do, but when you start looking at WebAssembly, at the spec and the core, you see that there's so much abstraction layers and people explaining it from so high above that it makes it feel or be more complex than actually going to the spec and reading the spec and writing an image to WebAssembly and seeing how few instructions there are, how clear there are, how well written the spec is. So it's a reverse. Like, people try to abstract to make it simpler and clearer, and they make it worse from my perspective. So, but also, like, as an opportunity, like, everybody is doing this, and we think that doing that will provide some alternative way of understanding it, but also seeing how simple, like how you can collapse the whole stack into just the mid arrays of numbers and you have a compiler. And also that's what we tried to do in the first chapter, and also in a blog post we wrote, is like, you can write a function and in like 20 lines of code you can have a compiler like that. But once you have the minimal viable compiler, then if you manage to line up the features one by one and grow it, every step is understandable and you feel the progress. It's not like install 25 tools, like make them work together, pass 20 flags, cross your fingers. So yeah, that's why we feel there was an opportunity to explain WebAssembly from another approach that was like that involved explaining less things and focusing only on WebAssembly, and also not because we expect every reader or any percentage of the readers to actually write a production industrial compiler or use it at work, but even if they are going to use them as a target, understanding what it is, how it works, the capabilities, the limitations, the trade-offs, but also like the capability, like what actually does, will help you. Even like the same with programming language or paradigms, you may learn something that you're not going to directly use in your day-to-day job, but actually knowing it expands your abilities, your capabilities as a software engineer.
So most people with a computer science degree have at some point in their university career been introduced to compilers with the so-called Dragon Book. Officially, it's called Compilers, Principles, Techniques, and Tools. Do you think it is time now to retire this classic textbook and teach compiler engineering with WebAssembly, and maybe ideally your course, I guess?
I think yes, in two parts. I think the Dragon Book has two problems. One is, at least from my perspective and from what I've heard and read, it's already seen as a scary book. Like, it has a red dragon in the front, so it already tells you something. But the other one is that it's also kind of outdated. I mean, the core concepts are still they still apply, like everything, and it's really good and useful. That's why it's the Dragon Book. Everybody knows what we're talking about. But the other one is like, it's everybody that tried to learn compilers by reading that book complains about like how hard it is, or it's harder than expected, or that it's outdated. So that book in particular, I think we should like phase it out. We can write something smaller and simpler and more modern, use modern tools like LLVM or WebAssembly. I would say WebAssembly because it's simpler than LLVM, but on the other one is like which language you use to write the compiler and which thing you target as you emit it. And if I remember correctly, the Dragon Book is C++, right? Or But any language that it uses and the target, the cool thing about WebAssembly is it's an instruction set that is designed from the ground up, that is simple, that has a formal spec you can go read in one place, and it explains everything, and that's formally specified, so like it's safe, it's good, it does everything it says it does, and it's pretty short. Like the spec it's not only short but readable, so it's a good target. Not only because of that, because it's designed, formally specified, has a good documenter that's readable and understandable, but also because you get the cross-platform for free. If you target WebAssembly, not only you get access to all this modern tooling that is built around WebAssembly, but now you can run on x86, on ARM, or in any other processor. Like, if we were having this podcast like 15, 20 years ago, like the default was x86, like 90% of everything was x86, but with mobile and like Macs, now ARM is a thing now. And so you get these things for free. You get access to great tooling, to good specs, to good design, and to cross-platform by default with all these optimizers. So I think WebAssembly is a good target. Of course, the other obvious one is LLVM, but it's a pretty big and complex thing to learn and understand, and the tooling is pretty big. And I heard people complaining of LLVM. So I think for teaching purposes, it's a pretty good target to teach. And also in general, if I want to be clear about this, writing compilers is not my main job. I don't do it professionally, but I use WebAssembly a lot as a target. I grab libraries and I play with it. So if you're playing with it, if you are interested in compilers, I think it's a pretty good choice to get started. So to sum up, like, I think we should write a better introductory book for compilers. We should stop referencing the drawing book, and we should target either LLVM or WebAssembly as the thing people use to generate compilers. I like targeting directly something simple and direct, because sometimes you think that more abstraction layers help, but for somebody starting, like, it's hard for them to understand what is what, how everything interrelates. So the least amount of concepts and tools and libraries that you have to introduce, the better. And that's what we try to do in the book. Like, the dependencies are like JavaScript and OM. That's all you need.
Yeah, we'll talk about OM in a second. I remember being very intimidated by the Dragon book, and I found a PDF somewhere on a website, I have to say. So I went to the library and got the physical book, and then it's like, oh, that's quite heavy, actually. And I remember learning a lot more from some practical courses where we learned how to use parse and Lex, I think, were the tools back in the days. Probably still are. So writing a grammar and then starting to parse, and then at some point we had a working bash, and then we could compile the bash in the bash itself that we wrote. So quite fascinating. So I think this is a way more hands-down approach for learning. So let's get into OM a little bit. So in one of the early chapters of the book, you teach the reader how to produce, and that's a quote, how to produce a WebAssembly module with a single function that does nothing and returns nothing. So, which, as you acknowledge, is not really useful. And instead, you then introduce the reader to something called OM. So OM, like the guy from the resistors, OHM. It's a JavaScript library for building parsers, interpreters, compilers, and more. Originally, this was created at the Human Advancement Research Community, HARC, at YC Research. It's a YC Research project. So since then, it's become a popular open source project. It's been used to teach programming languages at major universities, UCLA, Carnegie Mellon, and so on. So from your perspective, can you explain what OM is, what it has to do with the programming language Wafer that you use, and why you chose OM for your book?
Yeah. So a little bit about the history. So OM was actually born slightly earlier. So I was part of a research group that was originally called CDG, the Communications Design Group, which was started in 2014 by Alan Kay, who's, of course, Turing Award winner and worked at Xerox PARC in the 70s, and is known for creating Smalltalk and I think coining the term object-oriented programming. And And so Ohm was born out of our research there. And this same lab kind of in later years was funded by Y Combinator and was part of YC Research, as you mentioned. Um, and yeah, I worked on a team there. We were interested in coming up with new ways of programming, new kinds of programming languages, new kinds of programming experiences. And of course, if you're doing that, you need to make a lot of languages or prototype languages. And we wanted an easy way to do that. And so my lead, Alex Worth, had created a previous system called OMeta. And in principle, Ohm and OMeta, so Ohm was designed as the follow-up to OMeta. I started working on it originally, building a visualizer for it. And over time, I became sort of the primary maintainer. Have been working on it now for 11, 12 years or so. And yeah, originally our motivation was, there are existing tools out there like Lex and Yak, or Antler is another well-known one. I think especially if you're prototyping a new language, these kinds of tools are really great because you can create a new language in, hours or days. And if you're writing a recursive descent parser, say by hand, it's probably going to take you a little bit longer to do that. And so these tools really let you kind of bootstrap a language very quickly. And, you'll need to build either a compiler or interpreter for your languages. And Ohm was designed basically to just make it as easy as possible to do that in JavaScript. When we first created it, TypeScript was very, very young and not super well used. But over time, we've added better and better TypeScript support. But there are some aspects of the API where you can see it was designed for JavaScript in the old days when, you might do things like pass in an argument and based on the type of the argument, change the behavior of the function. So there's a few APIs that don't work quite so well with TypeScript. And yeah, we thought, we're teaching a book about WebAssembly. And if you look at books like the Dragon Book, I mean, I haven't personally never worked through the Dragon Book, so I did do computer science, but my compiler's course was taught in Smalltalk, which is kind of funny. The professor had an old set of slides because my university used to teach Smalltalk as its introductory programming language. When I started, Java was the language that they were teaching, but the prof was near retirement and didn't want to change his slides and said, you can understand Smalltalk. So I took it as an opportunity to actually learn Smalltalk. So that was my first compiler. But if you look at, the table of contents of the Dragon Book, there's about half the book is spent on kind of scanning and parsing. And while I think that's very interesting, there are lots of interesting things there. And especially if you're trying to teach core CS concepts, there's a lot of interesting material you can cover. If you're interested in learning WebAssembly or if you're interested in x86, you're more interested in the back end of the compiler. So the parsing part is not really the interesting part. And we decided to use Ohm in the book because it let us really quickly build up a language and not spend a whole lot of time on the parsing aspects. So basically, Ohm lets you, define a grammar that defines your language, and it will generate the parser for you. And that means that in the book, we can focus on basically the back end part. So going from, a tree, so a concrete syntax tree, and then focusing on the code generation part. And that lets us keep the focus on WebAssembly and not get bogged down by some of the, more esoteric aspects of parsing.
And that language is Wafer that you built as the course, during the course.
Yes, yeah. So Wafer was basically just designed to be a simple language that maps pretty easily, pretty one-to-one to WebAssembly.
I want to add something that it seems to be a repeating pattern and something we try to avoid in our book. When you mentioned, Tom, when you were studying, and you, Patrick, and I had the same experience. I studied software engineering. And in the compilers class, I was really, like, from the beginning, I was interested in compilers. And while I was doing that class, I was reading a book called Let's Build a Compiler by Jack Crenshaw. And that also influenced me in wanting to write a compiler book more modern. That one is in Pascal for Motorola 68K, and it was written in the early 90s. So I always wanted to do a modern take on that one. But while I was taking that class, I was writing a compiler by myself using the book and what I was learning. And I remember that, like, everybody in the class knew that I was the only one that was understanding why they were teaching that to us. And every week somebody will come and say, why are they teaching us this? Like, why is it useful? Because they were teaching it in the sequence that like basically in the sequence that you write the compiler. You write like the lexer and the parser and the EST and the tree manipulation and then the emitter. And probably you're not getting to emitter at the end of the semester or the end of the year. So you never see the result of learning all those things. And what we try to do in the book is just start with something small that works and that shows you why are we learning this and grow it. So you get a compiler that does nothing in the first chapter. Then you learn enough to have arithmetics and then a compiler that can do arithmetics. But all the time you see the end result. Basically, you have like really small shorts, feedback loops and increments of a compiler that always works and always does something. So you always know why you are learning something. Basically, we try to not like teach you everything you have to know and at the end write a compiler or like say, hey, this is why you have spent your last year or this whole book learning. It's like if you dropped the book at every chapter, you learned a small subset of Wafer. And at least for me, that's the kind of content I find engaging, and we believe that it's also useful for others.
Yeah, that sounds like a fantastic approach because, as you mentioned, typically the time runs out. So at the end of the semester, you don't even get to the crown jewels. Cool. So, Patrick, you've been recently working on a project to compile those OM grammars to WebAssembly. Can you tell us a little more about this? What is involved there?
Yeah. So, I mean, in the book, right, we take ohm grammars and using ohm compile Wafer to Wasm. And the project that I'm working on involves, so ohm as a library currently only works in JavaScript. And over the years, we've had requests from people to make it accessible from other languages, either to have a version of ohm that's available for Go, Swift, Rust, etc. And yeah, so I'm working on a project that makes that possible. And the approach is to basically, it's kind of very meta. We take the ohm grammars and compile that grammar to a WebAssembly parser, basically. So you get a Wasm blob, which represents a parser for your language. And that then means that you can take that Wasm module and from Go or from Rust or whatever, parse source code in your language. So for example, if you were using Wafer, you could compile the Wafer grammar to Wasm and then you could use Go to parse Wafer source code using your own grammar. And one of the other interesting aspects is that this project actually uses the library that we built in the book. So over the course of the book, you build up a small assembler library, I would call it, just a very, very simple single file JavaScript library that is essentially just shortcuts for, constants for the opcodes and some helpers for, doing the leb128 encoded integers, things like this. But using this library, you can emit Wasm modules. And so that's actually what I'm using in ohm to compile the ohm grammars to Wasm. So using kind of the end result library that you get in the book and using that in production for this project. So it's been a nice, confirmation, a nice test case for our library to verify that it's complete and that it works, and that we haven't kind of made any mistakes because a lot of the examples in the book are fairly simple, right? And so, this project is much more stressing the library in a real world use case.
Cool. Yeah, I love how meta this is because in the end, as I say, you prove to the thing itself that the thing itself does work. So that's really neat. So one of the things that surprised me, so at the end of the book, you mention that some things you didn't cover, and some of them even on purpose, not just because you ran out of time or space. But one of those omissions was the Wasm text format. What? To justify it, you write, we didn't cover the text format at all. Once you're familiar with the execution model and binary format, the text format is not really required. The concepts are all the same. It's just a different representation. And that's, of course, true. But when I think back of when I wouldn't claim that I really know WebAssembly, but when I tried to learn it, WebAssembly, the text format really helped me understand some of the concepts better because it's just a lot more readable to humans than binary. But yeah, you chose to not cover it. Can you tell us more about this choice?
Yeah, the first probably the main reason I just thought about it maybe is scope. As I mentioned before, we said 1 year, 100 pages, and it ended up being almost 3 years and more than 300 pages. But so as you said, like what WasmAssembly text format and Wasm the binary format are two different representations for the same concepts, which is the WebAssembly instruction set, and they target different audiences. Let's say like the binary format is for computers, but also for compilers, and the text format is for humans. So if we could, like technically we could build a compiler by emitting what, and the thing is that like it's pretty easy to debug because you can always print the thing you're emitting, but it will involve like concatenating strings or building some intermediate abstract syntax representation and then turn it into strings, which will make more code we have to write. But also that's not usually the way you write compilers. You usually emit like the binary instructions. So that's the first reason. Basically, the obvious choice to build a compiler is to meet the binary, and but that doesn't mean that, and also because like that's what compilers like and what computers like, and also because we don't need any external tooling or more code to turn like whatever the compiler is generating into text, or having a pretty printer or whatever. But that doesn't mean that the text format is not useful, or we say one is better than the other. In fact, we use like the text format a lot for writing the book and in general when playing with WebAssembly. The two that I can mention is when you are debugging your compiler, you usually use a tool to grab the binary format and turn it into what, so that you human can read it and understand it. But the other way we use it is when you're sketching a new feature for the compiler, we usually write a small what file by hand, compile it, see that it works, run the checker, run it, and say, okay, yeah, this are the instructions we are going to use, these are the patterns we are going to use, and then you turn that into the binary format. So they are complementary. Like the binary is for compilers and for computers, and the text is for humans. It's good for debugging, it's good for like prototyping. So it's useful to learn both. And you mentioned at the beginning, there's another resource, learn wasm.dev, I think it's the URL. That book is text-centric, basically. It's the kind of the opposite of our approach. So if you want to learn about the text format, that's a good resource. The other one is go to the spec. The text format is specified in the spec. And yeah, it's a useful tool. We could at some point add like an extra deep dive on the format. Also, because that even when what is a low level like syntax for a low level language, it has like two modes and a lot now some syntactic sugar. You can write like the Lisp style with parentheses where you nest expressions, and you can also write like the stack version where each line is an instruction. So you have to pick either one or explain both. And also there are some things that are useful for humans. There are some sections you can like not write, and what will generate them for you, like the type section. And we wanted to cover the whole spec, all the sections. So we will have to be explaining, yeah, you have to write this, but you can write it this other way. So it doesn't align to what basically we wanted to explain WebAssembly, the standard from the perspective of a compiler or somebody targeting the spec, and the binary basically, of course, maps one-to-one to the spec because the spec is the binary. The text format is for us humans to debug and to prototype. But yeah, I really recommend you to learn it, and we should probably write something in the book about it.
Just wanted to add that so a couple months ago, we did a short workshop with a few people in Munich. And when we prepared the materials for that workshop, we found ourselves leaning a lot more on WAT. And now that was a very different context. It was just a one-day workshop with about, I think we planned for 4 hours of kind of teaching time plus time for lunch and coffee break and stuff like that. And in that shorter context, we definitely felt that learning WAT was maybe the most bang for your buck. If you've only got a short amount of time, it's pretty understandable on its own. And it's very, very helpful to know if you're going to be debugging programs. So as Mariano mentioned, we use Wasm to WAT, all the time when we were developing the book, to just understand, what are we producing here? What's going wrong? Why is this not validating? That sort of thing.
Yeah, also the Wasm tools toolchain also has like a validator, a pretty printer with both formats, but also it allows you to pretty print invalid Wasm, which is useful because usually when you're debugging, it's because you generated the wrong Wasm, so that's pretty useful. And something else I wanted to mention is like if you know or like low-level programming like assembly, learning what is really fun and fast because it's similar to learning x86 or ARM assembly. And I did it's fun, at least for me or people like me. I wrote two things by hand in WebAssembly. One is a fourth interpreter, and the other one is last year I was like writing a series of blog posts of what the smallest object-oriented runtime, and at the same time we were thinking about if we wanted to add some chapters on WasmBC to the book. So I wrote a really small object-oriented runtime on WAT using the new WasmGC features because also I wanted to explore them. And both I wrote by hand in WAT. I don't know the percentage of developers that enjoy that, but it's really enjoyable. If you like writing WebAssembly by hand, you will enjoy writing WebAssembly by hand too.
Yeah, I definitely found it instructional to write WAT myself and then compile it to binary. I think the other way around, it's a lot less clear just because there's so much added boilerplate and noise that is parts that the tool generates for you, but that you don't really author by hand. So it's easy to get lost and not see what is the actual content that you authored. But the other way around, if you start by writing WAT by hand and then compile it to the binary format, I think that's, kind of instructional and helps you better understand what is going on. So you teased already a little bit WasmGC. So if you had all the time in the world, where would you pick up again for a potential part 2 of the book where you left off at part 1? Are there any plans to cover more recent post-MVP Wasm advancements, like, as you said, WasmGC maybe? What can we look forward to for part 2, if anything?
Sure. Yeah. I think the first thing that we've talked about is just updating the book for Wasm 2.0. So that was kind of made official or frozen or whatever the right term is. I think just a couple weeks after we launched the book, or a week or two before, I forget. There's not a ton of stuff in there. And so updating the book to Wasm 2.0, I think, is one of the things we've talked about. WasmGC is the other big thing that we've talked about. That feels almost like another book or, another supplement anyways. I think that's more than a single chapter. It really adds, I think, quite a bit to the spec, and would also require adding a lot to the Wafer language to sort of tie in the concepts that we want to cover. But that's certainly something that we've been talking about. And We also had someone in, so we have a Discord for the readers of the book. And just yesterday, someone was posting that they wanted to add types to Wafer instructs. And yeah, I forget what else he said that he wanted to add. Yeah, so I think Wasm GC would be a lot of fun.
Yeah, we have been. I've been daydreaming for the last year. That's something also interesting that happened. Is I was afraid because I've read and heard about many people that wrote books that after they write the book they don't want to write. They recommend not writing a book, and we had fun and we still like enjoy the process. And we have been thinking like, should we add chapters to this one? Should we do a second edition? Should we write blog posts? And what we're doing right now is a series of blog posts exploring more of the execution semantics by writing a WebAssembly interpreter or virtual machine. That probably is going to be a series of blog posts. It may turn into a series of chapters that we later add to the book or to second edition. The obvious thing is WasmGC, as Patrick mentioned, but the approach we have been talking about, and it's kind of, you can see it in Patrick's background. He has a poster there about the Pascal syntax. And I think a big influence for both of us that we didn't mention yet is the Pascal family or the Pascal attitude. Niklas Wirth, I don't know how it's pronounced. He created Pascal, Modula, Oberon, and his approach to like how much you can do with so little, or how you can like collapse the whole stack. He built in Zurich, I think. They built their own computer, their own operating system, language compiler, everything, the whole stack by themselves, like basically making it much simpler and approachable, and developed all by students in the university. And we were thinking like, because right now Wafer, where it ends, it doesn't have types because it has only one type, I32, and it doesn't have WasmGC. That it has arrays, but not the arrays in WasmGC. And we were thinking like, will be cool to make a second book that is basically a modern Pascal that compiles to WebAssembly and uses WasmGC, because the syntax is pretty simple, the type system is pretty simple, and it maps really well to structs and arrays from WasmGC. That's my dream. But now we are working on the interpreter to explore the semantics. Then we have been talking about like the exploring, maybe in also blog posts, the validation in the spec, like, because the validation phase of WebAssembly, it's kind of a really simple type system, type checker. So maybe explore type systems and type checkers from the perspective of the WebAssembly validation phase. And with that, like with the validation plus the semantics plus the Pascal plus WasmGC, I would love to write the second version that explores WasmGC, maybe exceptions, type systems. That's my dream. It may take 2.5 years, but we haven't started yet.
Yeah, nice. Well, we can definitely feel that you're very passionate about the book, the two of you. So I guess what most people don't really know about books, they don't really make you a lot of money in almost all cases. So you must be in for something else. And like in most cases, obviously, if you're writing Harry Potter, that's maybe something different. But like if you are in for writing a book about WebAssembly, your audience by definition is already relatively niche. And then, you have like a bunch of people who actually buy the book, a bunch of people who get it from library. There's people who pirate it. That's also something to take into account nowadays, unfortunately. But like when you wrote that book, in the process of writing, was there anything that you were completely surprised by, that you didn't expect at all?
I think there were a few things that surprised us. So very early on, we were very influenced by a book called Write Useful Books by Rob Fitzpatrick, I think it is. And he basically encourages, if you're writing nonfiction books, to get a lot of user feedback. And so we tried to follow that approach. And I think one of the things that surprised us was how difficult that actually is. So I think in reading the book, I had this feeling that, you get the feedback, and the feedback sort of makes it clear what you should change and how you can change the book to make it better. And what we found was that the feedback is often conflicting, or people give suggestions that don't really seem to make sense with the concept or the way that you've been thinking about writing the book. And so one of the big surprises for us was, just how much you need to still kind of rely on your intuition and your own taste. And to have, I guess we always had sort of particular ideas in mind of how we wanted the book to turn out. And certainly the reader feedback that we got was very, very helpful. It wasn't so easy to interpret at times. And I think that was a big surprise for us. And there's a thing that I like to tell people about the comedian Bill Hader. Someone once showed me a YouTube video where he talks about responding to feedback, and he said something which I really like. He said that when people tell you that there's a problem with your writing, so he's talking about, either I think writing or TV. When people tell you that there's a problem, they're usually right. When they tell you how to fix it, they're usually wrong, and you shouldn't listen to them. And I think that's really good advice. And I've done a lot of usability work in the past, and you have something very similar, right? You'll see people get confused about a certain part of the interface, and that tells you that there's something that needs to be fixed there. And often they will have suggestions about how to fix it. And, sometimes those may be right, but quite often they're not really the thing that you want to do. And I think as well, Julia Evans, who makes Wizard Zines, which I'm a big fan of, she has written something similar about responding to feedback and how, sometimes people will tell you things that they think will confuse other people, but that they themselves weren't confused by. And I liked her advice that you should prompt people to tell you the things that they were confused by, not the things that they think will confuse other people. So there's definitely an art, I think, to guiding your early readers to give you the right kind of feedback that's helpful for you.
Yeah, there's this famous reviewer 2 meme as well. Like after incorporating everyone, including reviewer 2's feedback, that's the paper.
Yeah, there are things that were surprising. It's the amount of tooling we had to build custom stuff for review. We started with Verso comments, then we built our own on top of hypotheses. Then we built our own server to host and manage payments and manage access. We also built to write the book, to put the code in the right place and make sure it's valid. We built our own parser, and we had to evolve the way we write the code and together with the tools so that it will extract the code for different use cases, like to embed it in the book, to test it, but also to generate snapshots at different places in the book. Everything is generated from the single source of truth, which is some code written with some comments, particular metadata. And we had to build a lot, writing in the first 6 months. I think the least thing we did was writing. we were growing this awesome, sending newsletter, mails, subscription list. We were managing and building everything. The amount of how custom writing a technical book is, there are some stacks, but if they don't add up to what you want to achieve, targeting the web and then trying to generate a PDF out of the web, that's a thing. Deploying, we approach it pretty much like a software project. We have a staging environment. We deploy first there, we try, then we have it's pretty much a software project in a sense. That's surprising. And the other one is how diverse the backgrounds of people getting involved in either providing feedback for the book in the Discord channel or also in the workshops. In the workshop, what had happened is that not a single person was a JavaScript, TypeScript first person. Everybody was, the main language they used was something else. And they really had either as a hobby or as a professional thing, a reason to want to learn WebAssembly. So luckily we try to use a pretty small, simple, readable subset of JavaScript, but like giving a workshop to 10, 15 people where nobody is a JavaScript first developer, it was a surprise. And that's also like, if you may make the Venn diagram of like people that want to learn about compilers, people that want to learn about WebAssembly, and JavaScript developers, like the intersection of that is pretty niche. So yeah, I'm still surprised how diverse the background, and they still read the book and they still find it useful. Like we try really to not introduce many like tricks or advanced JavaScript features, and I think that's a useful thing.
Yeah, cool. So I guess this already brings us to the last part of the show, which is, as always, Wasm but not. So when either of you instantiate streaming on any of your streaming devices, what is it that you currently watch or listen to?
So something in which I just finished, this is maybe an unusual choice for the audience of this podcast. I just finished watching season 2 of the Netflix series Quarterback, which is about NFL quarterbacks. And I myself actually don't watch NFL football, but I found this really interesting because, it's people who are at the top of the game or among the best in the world at what they do. And I find it really interesting to see behind the scenes sort of how they approach what is their work. And quarterbacks are particularly interesting because they are both amazing athletes, but are also very intelligent. And it was really interesting to see in this series how much time they spend studying, basically. Every one of them has a study routine of how they learn the playbook. So that was a series that I really enjoyed.
Yeah, I guess YouTube counts as streaming. And lately I've been following the talks at the conference called Better Software Conference that happened like I think a month ago. And in non-software topics, I started following Formula One again. When I was younger, I'm a Ferrari fan, and I watched like Formula One for like 10, 15 years. Then I stopped watching it when Ferrari started doing not so well. But this year, like there's an Argentinian driver, so I'm following it again. And I'm enjoying more like watching post-race analysis than the race itself. I mean, I watched the race, but I find more interesting to watch somebody that knows a lot about the topic to explain to me the topic than me watching the race. Even when I watched like 10 years of Formula One every day when I was younger. But like watching post-analysis of Formula One races is the thing I'm interested right now.
I see a pattern there. You're very deeply interested in a theory of things, and the thing itself, well, yeah. I mean,
I
it's
don't
a
watch
side thing.
NFL, but I watch quarterbacks things. I don't watch Formula One, but I watch analysis of Formula One.
Exactly. So next question is, if there's one thing that you could local get, as in something that you do, and then global set, as in something that you wish everyone else did, what would it be? And if you want, you can also reverse the question.
I would say that I would love to see more people writing technical content. So either blog posts, I guess long form technical content. So blog posts, newsletters, books, that sort of thing. I think more people, number one, I enjoy reading people who publish a lot. So if I can kind of give a shout out to some people that I follow and enjoy, Max Bernstein writes a lot of really interesting and accessible work on compilers and interpreters and virtual machines. Torsten Ball, a friend of ours, writes a weekly newsletter that I really enjoy. And I think I've had a blog for, close to 20 years now, have gotten a lot of benefit out of writing it. And I also love reading things from other people. So I would love if more people wrote technical content.
Mine is kind of related. The other side is I try to help, support, and promote people that are doing cool stuff and are small or don't have a big audience or don't have a big platform. I will name a few. I will forget many. like the Gleam programming language for the Erlang virtual machine is a big one. I really want to see them succeeding. Sonic Pi, a tool to do live music with a Ruby subset, is a pretty cool one. And in general, I maintain the Future of Coding newsletter that tries to make the activity around the Future of Coding community accessible to people that don't want to follow a Slack every day. Like every week I make a summary of things that's going on in that community, because in that community there's people like prototyping things, trying to make software better in different ways. So if you see somebody doing something interesting, try to help them. Like if you have a bigger audience, promote their work. If you can personally support them economically, if you work in a place that has a budget for education or consulting or open source, try to help the people that you feel should have a bigger audience but don't. And if somebody writes a cool blog post, like, and you find it cool, like, promote it in your whatever you can, basically.
Yeah, a strong response to both of those. Yeah, people sometimes get worried that something has been written about enough, so they don't write about it. But even if you do that, and there's a ton of material out there, you will learn something for yourself, I'm pretty sure. And yeah, as I said, boosting someone else's work, sometimes there's a lot of hidden champions. Someone spends a lot of time on a blog post, and then the thing they spend 2 minutes on gets featured on Hacker News, but the thing that they actually put work on, yeah, read by 3 people on the planet. So definitely use your audience, use your voice to boost stuff.
And the reverse also, like as a selfish thing, like every time I open the weekly newsletter from Thorsten Ball, like I open like 10 tabs. Like he promotes things he thinks are interesting, and I get like a curated thing of somebody I trust. So almost everything he shares I find interesting. So if you follow a couple of people that promote things niche that they find interesting, you get exposed to more interesting things. It's kind of a curated tree of of people sharing what they find interesting.
Yeah, absolutely. And every now and then you are in such newsletters yourself, and you're like, oh,
Yeah,
wow,
cool.
amazing. Someone notices. Cool. So talking about someone notices, Tim O'Reilly, if you hear this and you want to reach out to Mariano and Patrick about the book, or if you're an editor who is not Tim O'Reilly, or if you just are a person who is nice, who wants to say thank you, or just ask a question, or reach out with any comment, Patrick, Mariano, how can people reach you?
So we're both on Blue Sky and Mastodon. You can find links to our profiles in the show notes, and the same with we have accounts for the book as well on both of those platforms.
And you can, like, if you like RSS, which is a cool technology, we have a blog and it has RSS, and we have a mailing list. We are migrating the meaning of it from like pre-launch to maybe like updates every now and then. You can subscribe there.
Yeah, absolutely. Hit like and smash that subscribe button as the meme goes. Awesome. Cool. Patrick, Mariano, thank you so much for being on the show. It was amazing. I learned a lot about writing books, and like, I'm probably not going to do it, but if you have encouraged someone else out there to do it, definitely people survive writing a book. You are the walking proofs. Thank you again for being on the show. And if you're out there and you have something interesting to say about WebAssembly, definitely reach out. You know how to reach me. I'm Tomayak on essentially everywhere on the internet, whatever platform you like, except Twitter. You will find me there. And with that, thank you both. Talk to you. See you next time. Bye-bye.
Thanks. Bye.
Thanks. Bye.